Good afternoon, everyone, and thank you for joining us today. My name is Kevin Vita, and I'm a technical lead here at ITS America. I'd like to welcome you all to today's webinar, which is the fourth and final webinar in a four-part series we are hosting on Vehicle to Everything, also known as V2X. I'm excited about today's webinar, which will focus on factors in funding, costing, and procuring V2X deployments. This webinar series is part of a broader effort through which ITS America has been working closely with the U.S. Department of Transportation's Intelligent Transportation Systems Joint Program Office to support public agencies who are currently deploying V2X or might be interested in deploying V2X in the future. We are capturing all this information for the benefit of the industry and the deployment community. I wanted to mention a couple of quick logistical items for your awareness. Today's webinar is being recorded, and a copy of the recording will be posted to the ITS America website in the near future. We have also enabled closed captions for this session, and you can choose to turn them on by using the closed captioning icon, which you will find at the bottom of your Zoom screen. Finally, we do encourage you to provide any questions you have for our presenters within the Q&A pod. We may not have time to address all your questions at the end of today's presentations, but we will capture them for potential future follow-up with our presenters. So with that, I'm going to turn things over to our wonderful moderator today, Erika Kemp, who is the Strategic Initiatives and Innovation Division Director at Texas DOT, to get us started.
Hi, and welcome. I'm Erika Kemp. I am, as Kevin just said, the Division Director for Strategic Initiatives and Innovation here at TxDOT, and I'm very excited to be here presenting with you today. Let me see, I'm trying to get this to share. There we go. All right. I don't think it's sharing the right screen. It worked when we practiced earlier, so my apologies. I'm just going to end the show, and that way we can get through this. All right. We are here today to talk about Vehicle to Everything, which is referred to as V2X. It falls into the category of rapidly evolving transportation innovations. Some may even call it a technology disruptor. We have four powerful presenters today talking about their V2X projects and their lessons learned and challenges around funding, costing, and procurement to execute these projects. Before we get started, though, let's level set on what V2X means. V2X is the ability for a vehicle to communicate with its environment. It is meaning that it communicates with vehicles, infrastructure, and road users. It enhances safety, mobility, and efficiency by enabling real-time alerts and coordination, and it helps prevent crashes, reduce congestion, and improve traffic flow through smarter transportation systems. In the graphic, you can see here that it connects with vehicles, bicyclists, pedestrians, the home, the grid, the infrastructure, and the one item missing from this graphic is your mobile phone. Right, so the entire road environment. This slide shows what the ecosystem is made up of, which is more than just those assets or people that I talked about. It is all the digital infrastructure on the back end that's needed in order to make V2X work. And the benefits of V2X are to improve safety, enhance traffic flow, provide emergency response more rapidly, be cost-effective for infrastructure upgrades, and prepare us for the future. V2X is so important to us that the US DOT created the V2X framework in August of 2024. This framework aims to improve road safety, mobility, and efficiency by enabling communication between vehicles, infrastructure, and pedestrians. The framework includes a national deployment plan, interoperability testing, and a focus on both safety and privacy. The plan envisions a future where V2X technology is widely adopted and leading to a safer and more efficient transportation system. With this framework also came the opportunity for accelerating V2X grants from the Joint Program Office at USDOT. There were 3 grants issued to the Utah DOT, Maricopa County in Arizona, and the Texas Tech Transportation Institute here in Texas. And these 3 grants total nearly $60 million that are invested for proof of concepts for V2X frameworks for this national deployment plan. Let me introduce our first presenter, Ryan Huddleston. As the director of the Intelligent Cities for the city of Chattanooga, Ryan is focused on the deployment of V2X and other sensor equipment across Chattanooga's intersections while strategically developing Chattanooga into a leading smart city long-term. His unique background combines global strategy experience from the Hyundai Motor Group with extensive IT expertise as an application engineer and team leader. His presentation today will focus on V2X cost categories, funding avenues, and other key takeaways about Chattanooga's V2X deployments. Ryan, let me turn it over to you.
Yes, thank you very much, Erika. Just get my presentation up here. Okay, I hope that's visible now. Yes, as Erika mentioned, I'm the Director of Intelligent Cities for the city of Chattanooga, Tennessee. And I'm really excited to be a part of this ITSA V2X webinar. And I'm going to be focusing on factors in funding, costing, and procuring V2X deployments today. So just a bit more about my background. So I've worked overseas as a project coordinator for an EU framework program for a Korean research funding agency. Also worked for quite a bit of time for the Hyundai Motor Group in global strategy and marketing overseas. Then I made a bit of a career pivot into IT. I worked as a full stack developer, application engineer, and also led a team of application engineers as a team manager, mostly focused on Hilton hotels, which brought me to my current role of Director of Intelligent Cities. So just some of the topics I'm going to be touching on today: key cost categories for V2X, factors influencing V2X deployments, funding avenues for V2X projects, challenges that we've had here, and some suggestions on how to avoid them, and then some key takeaways from my presentation here. Okay, so I just want to get started with the key cost categories for V2X. So first of all, I want to talk about hardware, and I think some of the other presenters today will get into actual cost figures, which I will not be doing. But hardware-wise for V2X, we are deploying RSUs, roadside units, and OBUs, onboard units, here in Chattanooga. And then as far as software costs, or the software that we're using here, so the platforms associated with those RSUs and OBUs, and some of the analytics that come off those platforms also. And then on the installation and integration side, obviously we have labor costs and the cost of connecting to existing systems and platforms that we have set up here, which leads into setup and config. So, I mean, I think there are hard and soft costs involved in this. The devices themselves, the cabinets, the network, the cloud, whether that's external cloud or, one of our cloud platforms here at the city. And then we do have the operations and maintenance costs. So, our equipment may be grant funded, but we need to think about who's paying maintenance costs for all this equipment and all of these platforms after the grant ends. And then also how much skill and knowledge our staff needs to kind of maintain all of this equipment and maintain all of the, everything on the software side also, the platforms. And kind of in line with that, I thought I'd talk a bit about project scope creep. which I've kind of got this iceberg here to illustrate that. So you're purchasing these devices, which may be able to do X, Y, and Z, but you also need to think about what support you need for these devices on the physical infrastructure side, so that, like cabinets or whatever else. And then we've run into a lot of issues with unscoped issues, such as crushed conduit on mast arm intersections where we're installing these devices. So that's involved repair costs for us. And then, as I mentioned, back-end software and networking. So we're trying to get cooperation and power from a host of different divisions and departments across the city. And then you have your one-time buys versus your ongoing costs. I mentioned a bit before. Communication costs, this is something like fiber, ONT versus cellular. And then we also want to think about how the data is going to flow off these devices and where it's going to, and who we need to work with to make all of this happen. So this is how, some of these projects might kind of creep out of control. Currently, with the city of Chattanooga, our network is mostly focused on security. And so we've kind of had to consider efforts made to add new devices and software onto our existing network. And then also we've been having to think about how our software and firmware updates may affect our infrastructure, and if we're ready to support all of that. So just moving ahead a bit, I want to talk about some factors influencing our V2X deployments. I talked a bit about scope, but just looking at the scale and scope of our deployments. So we are deploying equipment through over about 100 signalized intersections, as well as several mid-blocks through downtown. And primarily that's coming through equipment funded from 3 federal grants that we have. On the technology side, so we're currently doing deployments from our SMART grant, and that grant itself was kind of designed to compare some V2X equipment from different vendors so that we could, make a decision on what works for us best within our city. And so we have questions, as we're looking at all this equipment from different vendors, such as, does the vendor have an integrated software platform? So we're trying to make those, decisions based on what the vendors offer. And then also looking at our existing infrastructure, as I mentioned before, we are using existing city traffic cabinets and poles. One kind of mundane or small issue that's kind of cropped up, you wouldn't expect it too much, but we've come to find out that we need to think about the footprint of our equipment in the cabinet size. It's become kind of a big issue for us, especially with these smaller M cabinets. And when you're putting all these devices out in the cabinets, we've kind of found out that we don't have room in a lot of cases to put all of this equipment in the cabinets. And then also you have to think about conduit and wiring obstacles, as I mentioned before. On the communication side, we're very lucky here in Chattanooga. We have fiber across most of our city intersections. But one caveat to that is we don't necessarily have fiber at our mid-blocks. And so we've still are having to make a decision on fiber versus cellular at locations like that. And we can certainly put a fiber ONT drop at a mid-block, but we still have to weigh that decision whether it makes sense. And then I just want to talk about funding avenues for V2X projects. So here at the city, we're pretty limited experience to date with V2X deployments and technology usage, prior to 2025. So we've really required a lot of vendor training and education. We've had vendors come over here and do on-site trainings with us. I just want to stress the importance of partnerships and contracts, especially when going into these grant projects. It's really useful if you already have contracts or partnerships with your partners or vendors. and then kind of understand what your grant allows for on the purchasing pathways side. For procurement decisions, we have made some sole source procurement decisions, and I want to give you an example of that. We needed a solution for mid blocks, and we found a company called Juganu based out of Israel, and they were as far as I know, one of the only companies in the world offering their product, which was a sensor built into a luminaire light that has RSU capabilities with a Qualcomm chip, and which works with OBUs. So that was kind of an example of a good sole source decision. And then purchasing agreements. So when we're moving forward with vendor decisions, it's good to think about existing partnership agreements for purchasing. And I know this is V2X, but for example, we had a purchasing blanket with a company called Southern Lighting and Traffic Systems based out of Atlanta, I think. And that kind of allowed us to quickly purchase Ouster LiDAR for one of our grants. I just want to touch on some challenges we've had here and maybe how to avoid them. So for device checkout, since all of this equipment is so expensive, we've really focused on maintaining detailed logs and records of any equipment checked out of our inventory, and make sure we're double and triple checking everything. And then installation costs. Here at the city, they require very precise information on costs, especially when using external suppliers for labor. Things like what material that is going to be used, who's going to supply it, who will handle the equipment, and exactly at which locations. So just be kind of real clear about your installations, and get all the details down. And then the installations themselves, we've want to make the first install the right install if possible. So, make sure the devices are at the proper height with the proper orientation. You have grounding for these devices if you need it. And for example, you might need the correct Cat6 shielded and not just any Cat6 cable. We've had some on-site training where we've learned about security certificates for OBUs. So we're still learning as we're installing. So it's important to kind of get all that information in front of you as quickly as possible. And then just a few key takeaways I hope you can take out of this presentation. So ongoing funding and manpower costs, you need to be aware of ongoing costs to do with this equipment, to do with all the equipment you're installing, as I mentioned. And then the scope creep, this goes back to that iceberg a bit. Just think about what you think you're scoping for the project versus what you're actually having to handle. Using existing infrastructure, think about the best way to make use of the existing city infra and the best way to deploy to that infrastructure. And then your partnerships and vendor understanding. Just try to understand the projects and partnerships within those projects, and think about how to vet vendor products correctly. And thank you so much. And I think that brings my presentation to a close. Thank you for letting me be here.
All right, thank you, Ryan. That was very informative. I should have mentioned earlier, we are going to wait until the end to do Q&A. So I have seen a couple of questions come in already, but we're going to hold those because we do have our next presenter queued up and ready to go. Danielle Deneau is the Director of Traffic Safety for the Road Commission for Oakland County in Waterford, Michigan. She graduated from Michigan State University with a bachelor's degree in civil engineering and is a licensed professional engineer in Michigan. Danielle has worked for the RCOC for over 31 years and has held various positions, all related to traffic operations. Her current duties include overseeing the design, maintenance, and installations of traffic signals, pavement markings, signs, and guardrails. She also oversees RCOC's Traffic Operations Center and Intelligent Transportation Systems, including connected vehicle initiatives. Her presentation today focuses on the Road Commission for Oakland County's experience with CV installations. Danielle, would you, oh, there you are. All right.
Yep,
Thank you.
I'm here. Just give me a second to share. Okay. Good afternoon. Thank you for having me. I'm very excited to share with you what we're doing here in Oakland County. So just a little bit of background about the Road Commission. Safety is our top priority, and that's something that's very important and very critical to us, and I'll share a little bit about that later. But just to give you a perspective, Oakland County is located in Southeast Michigan. We're about 900 square miles. We have 63 cities, township, villages, over 2,700 miles of county roads. We still have about 750 gravel roads in the northern and western portion of our county. We maintain all the electrical devices and traffic signals in the county except for one city. So we're the maintaining agency for a lot of the cities and villages, including MDOT as well. So our fast track system, this program started in '92, and it just encompasses all of our ITS projects and our connected vehicle projects. So this fast track started in '92. We installed some adaptive traffic signals. We've expanded that now. We have over 850. The majority of them operate SCATs, but we do have, I believe, over 50 that are we're bringing online with SunTrax. We have the system across the county. We also have over 200 CCTV cameras, which we have 2 more projects to install more over the next few years. And we communicate to all of our traffic signals, or at least the ones that are on our adaptive system, through a wireless communication system. So this is just a graphical depiction just to give you an idea of Oakland County. All those colors mean different various devices, but that you'll notice that the majority of our devices are in the southeast portion of the county. And this just shows you where we have some of our CCTV cameras. And as I said, we're expanding that as we go. So a little bit about the Road Commission's connected vehicle background. We have been involved with connected vehicles for over 20 years. We've been part of several committees. My boss, Gary Petrovich, has also been involved. So we're always looking to see what's new, what's coming, and we've been kind of monitoring the progress of connected vehicles over the years. So we've done a lot of pilot installations or installations with some of the OEMs. The National Proof of Concept was installed in 2007, and that was 45 intersections. RSUs were installed at 45 intersections, and it was a demonstration project to show that the vehicle and the infrastructure could communicate in a timely and efficient manner. So it was very successful, and we keep moving forward as far as that goes. One of the things we are a big partner with MDOT. Several years ago, we installed RSUs across a number of their corridors, and they were all DSRC radio. So when the FCC changed to the V2X radio, they're all still out there as DSRC. So we haven't worked with MDOT yet to figure out what they're going to do, if they're going to change them, move forward. We haven't really quite figured that out yet. So, but this is, again, just some of the intersections or the pilots that we've done here in Oakland County. So I wanted to touch on our safety story. So in Oakland County, the fatality rate that we have in Oakland County is less than half of the state and national rates. And it's something we take a lot of pride in. We work very hard at trying to make our roads safer. And for us, the next step is obviously connected vehicles. So the first deployment that we've done was on 14 Mile, which is in the city of Troy. It was installed in the summer of 2023, and it encompassed 7 intersections. So like I said, it was the first deployment. It has SPAT and MAP messaging. We installed UNIX, CV2X RSUs, and radios. The reason we selected this corridor was because all of the traffic signals were going to be modernized as part of a road project. So it just made sense that we're putting all new equipment out there. This would be the ideal time to try this. So an electrical contractor installed the RSUs and associated equipment, the brackets, the cables. And then we had consultant support through WSP to help make sure they were programmed correctly and the SPAT and MAT messaging were there. So the funding source was a federal aid project, and RCOC contributed a match to that. So one of the costs that I put out here was just the RSU. So that was actually bid, the contractor bid on that, and that cost was how much it cost to, one, provide the unit and install the unit. I didn't get into the ranges of, the cable or the brackets or anything associated with that, but this was just, this was a contractor installation. The road commission built all the cabinets for the new traffic signals, but the contractor installed the majority of of everything else associated with the project. So I call this procurement. It was a design bid build project, just like your standard road project. Oh, and I just should also mention that we're not remotely monitoring any of that technology yet, but I'll mention that in the next steps. And part of the reason why we didn't jump is that the technology, it seems like, has been evolving. It keeps changing, and we didn't want to make large investments in our infrastructure as far as connected vehicle technology until we had a little better handle on what was going on. So one of the other projects that we had, like I said, we really only have two right now in the county, was the SMART grant. We got a SMART grant in 2022. The overall goal was to build an economically sustainable safety model and prototype deployment of V2X, but it was also looking at how to monetize or being able to fund these projects and maintain these projects. So we equipped 5 intersections in various cities around the county. We installed 10 OBUs and RCOC vehicles, and all of this was completed in the spring of 2024. The primary use cases that were being looked at as part of this project were vulnerable road users and signal priority, also V2X fleet intelligence. They're using an extended transportation spectrum. Right now, we're in the process of finalizing the project report. So we installed CODA RSUs. The road commission staff installed the RSUs and the cameras, which I believe were they were grid smart cameras. That was our contribution to the project, was to provide the staff and equipment, or the staff and the labor costs to install the devices. It took about 1 day to install the RSU and the grid smart camera. The funding source was the US DOT SMART grant. The RSUs, edge devices, OBUs, the software, and the cameras are listed there. The procurement, so from the SMART grant, the project consultant, who was P3 Mobility, actually provided the RSUs, the OBUs, and the edge devices. The road commission provided the grid smart cameras, and we did have to change out some of the controllers at the intersection so that they could be connected to the devices, which was kind of interesting because some of these intersections we thought would be ideal candidates, and then we opened the cabinet and realized, yeah, probably not. We might have picked a different intersection, but these were the ones we were going with. So again, a lesson learned. So some of the next steps, we don't have communications to these intersections. We're not remotely monitoring these devices, which is something that, we need to look at. We're also trying to figure out, again, our next steps. Where are the funding sources going to come from? We will be applying for a stage 2 SMART grant to extend the grant that we got in 2022. But also, I think, as Ryan mentioned, we have a lot of our road projects are done with federal aid. So we will try to see where we can incorporate them. Even the SS4A grant that is out there, we're looking to potentially add some more signals or more intersections through that. So But again, it's a learning curve. We have a lot of experience in ITS, and this is still a whole different animal. But like I said, safety is our top priority. So that's why we're looking to new innovations and what can we do and how can we fund it going forward. So that is all I have today. Thank you for your time. I appreciate it.
Thank you, Danielle. Again, if you have any questions for Danielle or in general, please put them in the Q&A and we will address those at the end of the webinar. Our next speaker is Blaine Leonard, and he is the Transportation Technology Engineer at the Utah Department of Transportation, with responsibility for the evolution and deployment of connected, automated, and other related transportation operation technologies. His team is at the forefront of connected vehicle deployments. Blaine is active in many national committees focused on ITS and connected automated vehicles. His presentation today focuses on Utah DOT's V2X costs and procurement. Blaine, do you want to turn your camera on?
Sorry, Erika. Thank you very much. I realized I was already had my slides up and then I couldn't find my mute button. So sorry about that. Thank you very much. I appreciate the opportunity to be with everyone today. Thanks everybody for joining, and thanks Erika and Ryan and Danielle for all the good information you presented. Hopefully I can add to that constructively here. So as we talk about procurement and deployment of V2X, I'd like to start with just a couple of big picture issues that we've encountered over the years. Deployment of V2X and by extension, procurement of V2X equipment isn't necessarily easy. It's different than the other things that you may have done, that we may have done, and it's fairly unique. The systems are still a little immature. They're much more mature than they were 6 or 8 years ago, but they're not yet quite plug and play. The devices and the standards behind them are still maturing. There are subtle differences between various products, and that provides us some challenges. And Danielle talked a little bit about that. There is a learning curve to this technology. It takes some time. And so if you have interest in this area and see your agency doing something with it in the long term, get started now. This can be done, despite the fact that it isn't easy. Don't be afraid of it. Start small, jump in, make sure your intersections are ready with modern controllers and backhaul and the right cabinet size, as I think Ryan talked about. Explore some trial procurement options, buy a few devices for trial before you commit to something larger. And when you do a general procurement, keep in mind scalability. Even though you may be buying just a handful of devices up front, make sure the the procurement keeps you open to larger purchases in the long term. And as always, phone a friend. There are a lot of agencies and private sector companies that have done this work around the country. Feel free to reach out to those, your neighbors in adjacent states or cities, and we need to learn from each other. Everything that I know about this technology, I've learned from others in the process of doing this. That's how it works. So phone a friend, get some help. Don't try to do this all by yourself. So with that, let me just give you a little background of deployments in Utah. We've been deploying since about 2015, with our first active deployment coming online in 2017. We currently have over 500 roadside units. The map shows you where they are. Most of our deployments are in northern Utah along what we call the Wasatch Front, where most of our population lives. If you look really closely at the map of Utah, you'll see some deployments that are underway in the southern part of the state and some communities there. But most of them are in the Wasatch Front deployment area. Most of those are at signalized intersections. Some of them are at intersections owned by a couple of our city partners. A few of them are along non-intersection corridors, Interstate 80 and some canyon roads. We've equipped buses from the Utah Transit Authority, snowplows, fleet vehicles, and emergency vehicles that are ours or belong to some of our partner agencies. We currently have another 350 RSUs being installed. Most of those are in place now, but not fully integrated. Again, most of those are at intersections, and another 200 vehicles. As Erika mentioned at the outset, we're one of the deployment sites selected by the US DOT to show how to accelerate V2X deployment. Our project is called Connecting the West. It involves Utah, Colorado, and Wyoming as partners. One of the things we're intending to show there is interoperability across jurisdictional boundaries, state lines. We'll add another 450 intersection RSUs and another 150 interstate RSUs. Colorado in this project will add another 150 RSUs along I-70, and we'll equip some more vehicles and use LiDAR to equip some sites to identify pedestrians and bicyclists. So that's sort of the scope of what we've been involved with in the last 8 or 10 years. And that forms some of my thinking about what we can do and should be doing. These deployments will get us beyond some of the early term goals that the US DOT set in their deployment goals that they issued late last year, that I think isn't available on the website today, but some of us still have copies of it and are using it as a roadmap as we deploy going forward. So as I thought about this a little bit, I thought, okay, what is it that we need to procure? What is this discussion really about? And there are some obvious things, and I think some less obvious things. Obviously, roadside units and onboard units. There's mounting hardware, poles, cables, connectors. Sometimes we buy OBUs, and for a particular use, the antenna that comes with it isn't adequate for our use case. So we buy external OBU antennas. They have to be compatible, of course, with the OBU. The CTI 4501 spec calls out something called an external control local application, an ECLA. In UDOT parlance, it's a signal command module. It's essentially a small computer, a Linux computer in our case, that sits in the signal cabinet that does some of the applications and communicates between the signal controller and the RSU, handles message creation and other things. You may or may not need something like that. We have a similar device on our vehicles that finds out whether the bus is behind schedule or the plow is actually plowing snow before it allows it to request priority or preemption. You may, in certain applications, need a human-machine interface, a tablet, a screen, a heads-up display in the vehicle to communicate with the driver. A lot of applications don't need that. Some do. You, of course, need applications. That may or may not come on the onboard units or the roadside units. It may be created external to that. And, of course, you need to have security certificates to support all of the messaging that goes back and forth. All of this needs to be procured somewhere or another. You might also need, if you're upgrading your signal cabinets, a fiber switch. We've upgraded our fiber switches with RSU deployments to have a power over Ethernet switch in them so we can remotely power cycle the RSU. That's a lot simpler than driving out to the location. You may need a power over Ethernet injector to power your RSU. You might need a surge protector. You might need to replace the signal controller. Depending on application, you may need LiDAR or cameras, and Danielle talked about some of those. So those might be things you need to procure. As your system gets a little larger, you're going to need some kind of an online system to manage the health of your RSUs, collect data, share the data. We have such a platform. Those need to be procured. In fact, our current platform is ending its contract. We have an RFP on the street literally today to replace that particular platform. And of course, depending on what your agency chooses to do in-house versus out-of-house, you will need technical services for system design, creation of maps, registration of your RSUs with the FCC, installation, integration, validation. If you're going to connect to the controller area network in the vehicle to get good, robust data out of the vehicle electronics. You'll need someone to do that CAN connection and decoding, which isn't trivial, I'll add, and maintenance and operation services. So there are a bunch of things that we need to ultimately procure. Here are a few challenges that we've run into over the years as we've procured and developed deployments. What we're needing to procure here is quite often different than what our procurement staff and we as agency engineers are used to procuring. Our systems are built around asphalt and guardrail and signal poles and plow blades and all of those kinds of things. What we're procuring is different than that. It's not as mature as that. It's harder to define as that. Keep in mind that you've got made in the US rules that may or may not apply depending on your funding and how you're going about this. You may have state rules about some of that. There are some federal exceptions that have existed for some of these electronic devices. Some of those are going away. And that all affects the procurement process and sometimes makes it difficult as you work with procurement folks who are used to these standardized products and you're throwing in things that are a little fuzzier, I guess, if you will. That can be a challenge. I've always found it difficult to describe exactly what I'm trying to buy, especially with something that is fairly new. Do I know enough about the product to really specify it? Am I building requirements into my procurement document that I don't know whether they can meet or not? If I know there are various vendors and those products vary based on their capabilities, how do I define that? If I want certain applications, some vendors may have it, some vendors may not. You've got to figure out how to write that into the procurement so you get the features you want, but don't get bound into something that you don't want. Again, you can phone a friend. There are peers around, peer agencies all over the country that have done this. The best way to engage is through some national working groups, ITE, ITS committees, Connected Vehicle Pool Fund Study, AASHTO, many others. But what I've noticed is I've borrowed procurement instruments from other locations is that they often approach it differently than I am approaching it or need to approach it. They may have different requirements. They may be bundling things in a different way than I am. And so you've got to be careful of that, but it can be good material. On-the-air certification and other certifications are becoming more prevalent, and it's good to reference those. I quite often don't require that certification in some of my procurement because I'm not sure that everybody's there yet and that everybody can meet all those requirements. I have them describe to me what their current conformance is with these certifications so I can make an informed decision. The standards are also evolving. Some standards require features that aren't available in the market. I mean, try to purchase a single controller that meets O3A or O3B. Not all controllers, most controllers don't meet that yet. So you have to be careful with the standards. I refer to them, I talk about them, but I'm a little careful whether I require them. Some of the features are not consistent, and so if you've got a cost element of your procurement, it's sometimes hard to compare them. If you're buying a management platform, for instance, if it's a sole source platform, if it's an open source platform, it might not have a license fee, but if it isn't, it is. You've got to figure out how to compare those. You've got to consider delivery time. Some of our long lead time items have been wiring harnesses and mounting brackets. And then you need to make sure that you have built in some time to make sure the equipment you purchase actually meets your needs. Finally, we just ordered some equipment to try to beat an apparent tariff, which is going to hit in July, as we're buying equipment from Europe. So that can be it. So I'm running out of time here. Our costs may vary based on how you approach it. Here's a list of some components you need to think about as you look at costing out your project. Here are some basic ranges that we've experienced with RSUs, both raw material and installed cost, and OBUs, and some of these other devices. I think these slides will get shared, and so you can look at these, but those are the ranges that we've experienced. I've referenced the ITS America V2X deployment plan, which gives a ballpark for the overall cost of deploying about 100 RSUs along a corridor. And here are some resources that have some really good information for you as you go to deploy your system. So with that, thank you very much for allowing me to be part of this webinar today. I appreciate it. I hope there was some information in here that was useful to you, and we will turn it back to Erika and then to Virginia. Thank you.
All right, thank you, Blaine. As always, very informative. And there was a question about, will the slides be shared? And the answer is yes. So you can get that list of resources that Blaine shared with you. I'd like to introduce our last presenter, Virginia Lingham. She is a Senior Vice President and National ITS Lead with WSP with over 20 years of experience in the transportation industry. She specializes in leading innovative projects that bridge the gap between research and the implementation of emerging transportation technologies, including the evaluation of business models and procurement and funding strategies for both public and private sector clients. Virginia is currently the co-chair of the ITSA Workforce Development Community of Practice. Her presentation today focuses on the ongoing project on procurement with the V2X pooled fund study.
Thanks, Erika. And it's an honor to be here with this great panel talking about procurement strategies, and different factors and funding, costing, all this to advance the V2X deployments. I do just want to stop for a minute. We've had a lot of presentations so far, but just to offer, a use case, a day one use case of why this is so important. One of the day one use cases that we often talk about when we're figuring out how to deploy V2X solutions is red light running, and whether that's a red light warning or red light stopping a vehicle from running a red light. We found some statistics that 23% of people confessed to running a red light, while 21% reported engaging in aggressive driving behavior, such as tailgating and frequent lane changes. And the current guidance from AAA says, use good judgment, tap the brake to let somebody know that you're stopping, drive defensively, prepare to stop. And we can really do more. We can do more with our V2X solutions and to improve safety on our roadways. So I'm going to talk, like Erika mentioned, I'll be talking a little bit about a V2X pooled fund study project that WSP is currently working on. Part of it ties into the information that Blaine was just sharing. And I have ties to this group because previous to joining WSP, I was with Virginia Department of Transportation, serving as the technical lead for this pooled fund study when it was still called the Connected Vehicle Pooled Fund Study. It's going through a name change right now. And this group was formed in 2009. So it has like a very long history of multiple projects, all to advance V2X and connected vehicle technologies. The objectives are shown here. Those are 4 top objectives for this pooled fund study, just to give you a little context if you haven't heard of it before. One of the objectives is to provide technology transfer support to state, local, and international agencies, as well as to facilitate that coordination with OEMs and other in the transportation industry. Another objective of this group is to provide input to other national groups like ITS America, AASHTO, SAE, and other cohorts that are existing over the years. Another one would be to establish multi-phase program for research. And so I'd encourage you to go to their website and check out all the great research that's been going on over the years to advance V2X solutions. This procurement project, which I'll get into in a moment, it really builds from that history of projects and experience with deployments. And then lastly, the last objective here is to aid transportation agencies and OEMs in justifying promoting large-scale use of connected vehicle environment applications through modeling, deployment, engineering, and planning activities, which is great because that's really where we're at now, is scaling this technology and really making it available to more and more agencies and more of the public to be able to take advantage of these technologies. So this project is called the Model CV Procurement Documentation Project. Its scope includes developing V2X procurement guide, participating in V2X standards activities, conducting stakeholder interviews with a variety of stakeholders, which are actually currently underway. Those include different agencies, IOOs, equipment providers, academia, folks like that. So to get that input on where the state of the industry is really at. And then the last piece, which is really important, is connecting with those who need it most. So kind of like connecting with this audience here, is doing that outreach to share what the findings are, to share what the requirements, what the recommended requirements would be for successful procurements. This project wrapped up late last year or it's kicked off late last year and will wrap up by the end of this year. The challenges that this project is really trying to address is that, kind of like Blaine mentioned, he hit on some of these too, but the current V2X system hardware and software does not really meet the V2X integration and interoperability requirements that agencies and others would like to see. They're trying, it's getting there. We've made great progress over the past, definitely over the past 6 to 8 years. I would even argue in the last year that things are getting closer as we scale and deploy more and more. And as things like the FCC second report and order is in place, and that helps companies make decisions on how to design their equipment to make it better, easier to integrate and more interoperable. Also, agencies and operators might presume interoperability, but this assumption can sometimes be incorrect. It could be really great intentions, but once you get in the field, you might find some challenges that you may not expect. Then post-deployment updates to resolve issues are both costly and time-consuming. We heard about that in when some of the earlier presentations too. It's like when you're going out there and deploying to go back and fix things, you don't want to do that. You want to minimize that if you can. And then lastly, there's limited incentives and kind of enthusiasm all among V2X deployment manufacturers to prioritize their progress towards interoperability. So, but I think that that's another thing that is likely changing. But this project is really meant to address these challenges. So the main objective of this project, again, is just procurement documentation. So to really equip agencies and operators with reliable future-ready resources, simplify the process, make this project progress towards interoperability much more available for whatever deployment you're working on, big or small. And then to implement and deploy V2X technology in a consistent manner across regions, across corridors, across multiple states, just make it much more consistent. And this will also help the equipment side and the vendor side of the house too, because this project also seeks to provide a clear understanding of what's needed from the vendors so that they can be prepared to respond to those RFPs, to provide the equipment. It really seeks to drive innovation from the vendors while remaining both practical and achievable. And we don't really want to discourage developers and vendors from engaging or responding to procurement efforts. So we want to encourage them to be ready to respond, to quickly respond, and to meet the needs of agencies and those who are putting out the procurements. So qualities of a good procurement document. So it needs to be well organized and user-friendly, really ensuring the clarity and ease of navigation for everyone to understand what's requested, what the need is, and how to deliver it. Next would be independently extractable requirements. So allowing specific requirements to be easily identified and referenced. So if you're referencing a certain standard, where do you find that standard? Who developed that standard? If there's other requirements, just making it more easy to find those requirements. Comprehensive procurement packages, so something that serves as a complete resource covering all aspects, so not just little bits and pieces there here and there. It's easier to respond and it's easier to have a meaningful solution if it's a whole package. And then lastly, the life cycle based requirements, so considering this full project life cycle, planning, design, installation, testing, validation, replacement, maintenance, operations. I think as we move beyond pilots and into integrating V2X technology fully into our ITS and operations programs, this is more and more important. Some requirements examples. So something that we're exploring is, roadside units. Should they be OmniAir certified? Identifying the specific requirements for SCMS procurement. A list of applications to be supported. That's really important to share. So this project is coming up with specific requirements, examples, and we'll document that and socialize it with a broader audience. So this outreach will be coming soon. So again, the stakeholder interviews are underway. We may be reaching out to some of you on the call today. Then we'll be preparing outreach materials to promote the project outputs and facilitate their adoption and use. And this is really important because this group with the the V2X pooled fund study, it's about 20 members, maybe a little more, different agencies who have been participating. There's a lot of lessons learned there that they want to share, and that this project is meant to really document and gather to get the word out so that others who are newer to the deployments can take those lessons learned and go build from them. There will be additional presentations and outreach to the ITS community, both state and local, starting later this year, probably Q4. I also did want to share, both Erika and Blaine mentioned it, but the V2X accelerator grants and projects are well underway. I'm personally involved as project manager for the Maricopa County project in Arizona, the Connected Vehicle Accelerator Zone. This image here on the left is from last Friday when we were all in the field talking about transit applications, and got some folks in the field to really touch and feel and see what the equipment was like. So that was really helpful. But in all of these three projects, as they seek to scale, we are actively collecting lessons learned. We are working through the procurement issues and challenges of procuring at scale. And we really expect that there'll be some really nice lessons learned that we'll be able to share with the next wave of deployments as this continues to scale. So I'm really excited, and I'm excited about the collaboration that's happening between these three sites, and even more excited to see this grow beyond these three sites. Lastly, I just wanted to touch on, like Erika mentioned, I'm a co-chair with Dara Wheeler with Caltrans and Tiffany Fuller with New York City DOT on the ITS America Workforce Development Community of Practice. We do talk about this. We talk about the need for training procurement staff, for just having a broader understanding of different technologies. Our objectives here on this slide are, we really seek to enhance the skills, knowledge, and readiness of the ITS workforce, which includes things like V2X technologies, AI, all different sorts of things. We also focus on cross-cutting issue areas. And then lastly, the overall goal is to promote workforce development by fostering these skills and opportunities to really address the evolving transportation challenges. Things are always changing and evolving in transportation, which makes it such an exciting field to work in. So how do we share that excitement with new people who are in the field, and also grab the knowledge and help with the sustainability of the industry as we're experiencing changes and other things happening. So the images here, the Community of Practice did develop this Workforce Gaps in the Future of ITS report. So that's available on the ITS America site. There's also workforce elements that are part of the blueprint for transportation technology, and then the surface transportation reauthorization policy principles, which came out earlier this year. All right, back to you, Erika. Thank you so much.
Great, thank you, Virginia. We have had so many questions come in. We are not going to be able to answer all of them, but let me start with this one question, and we'll just do a round robin. So we'll go with Ryan, Danielle, then Blaine, then Virginia. With the high tech, are you all making longer term contracts with system suppliers and equipment vendors to support the update for advances in the standards and security? Related obviously to V2X. So Ryan, if you want to kick us off.
Yeah, I mean, as ITS is going towards more, seems like it's going more towards IT, traditional IT, and obviously security is a big part of that. And we've discovered, things like OBUs needing to have security certificates, and that depending on what type of vehicle it is, also whether it's a preemption vehicle, you might need your security certificates being updated more often than just a regular passenger vehicle. So I guess, what was the rest of that question?
Let me scroll back to it because I had moved on.
Okay.
So really, it's about the longer term contracts, and then are we looking at equipment vendors to support the updates as this technology continues to advance?
Yeah, I mean, I think it's a good question. Obviously, we're kind of just right now touching the surface on V2X, so we're getting started at this point. But as we get deployed, and we've got a much larger deployment that's going to be starting soon. So as all those devices get out there and get deployed, I think as time goes on, we're going to have to consider the security implications of having all these devices out on our traffic network. But it kind of blends into other stuff that we're doing, like provisioning our traffic network with L3 switches for security. So yes, it's definitely on our radar here.
All right, great. Thank you, Ryan. Danielle, is there anything you'd like to add from a county perspective?
Sorry, can you repeat the question again?
Sure. Let me go back to it. So are we making longer term contracts with our system suppliers and the equipment vendors? And are we looking at support for the updates for advancements as the technology is, continually to be enhanced?
Well, from our perspective, because we're not outright buying the RSUs and some of the associated equipment, it's come through to us through the SMART grant. So we haven't figured out the 7 that we have on our 14-mile project. We haven't figured out if anything goes wrong with that, what do we do? So for any traffic signal equipment, which I'm assuming would be very similar to this, is that we would have an annual bid. We would go out for bids to get some of this and have an annual kind of project list or list of materials that we would be able to get going forward. I guess that's kind of my take on where we would go with that.
Okay.
If that's right.
Yeah, thank you, Danielle. Blaine, do you want to add anything?
Sure. Thanks, Erika. And thanks, Bob, for the question. I think this is a great question. It's something that I'm not sure we've always done a great job of. This technology is advancing. There's always new firmware upgrades. There's always new standards to meet. And we're trying to write into our procurement documents some of this future proofing. So we've got, so you can add in, support this equipment for X number of years, provide us with updates, those kinds of things. And then we're trying to make sure that as our local integrators and installers become more and more familiar with the equipment, they're able to provide some of this ongoing maintenance. And we're trying to develop a relationship between them and the equipment vendor and make sure they have the information they need. As we test and try out equipment from vendors, I make it very clear to the vendors that their equipment may or may not work for us, but one of the factors we consider is how well they support it. So if we run into a problem and can't make it work and we contact them and 3 weeks later we've not heard from them, well, that equipment doesn't go on a pole anymore. I go to somebody else. And so it's important to develop these relationships and to write into the documents and be willing to pay for some of that ongoing support.
Great. Thanks, Blaine.
I'll just add that I think it's all over the place. I have clients that are entering into 10-year contracts with certain providers that it's pretty long as far as to provide these services and then offer the support under like a 10-year time frame. With the V2X accelerator grants, we're doing, it's a 5-year operations and maintenance requirement that is expected with that. So I think that that's more typical. And then some are still kind of more pilot focused and demo focused. So those are a little bit shorter time frame, more like demonstrating the technology and then figuring out what to do with it next. So really, I just feel like it's all over the board depending on your familiarity with the equipment and the technology and really what you're trying to do.
Okay. Thanks, Virginia. All right, I'm going to combine a couple of the questions together, and this is really for Ryan, Danielle, and Blaine. And Virginia, if you do have any comments after they've spoken, please feel free to jump in. But who are the recipients of the information and what is the information they're receiving? So I know there was some discussion about vulnerable road users that are receiving information, but there's also the onboard or the OBUs. Ryan, do you want to start with who's actually using this information coming from the RSUs?
Yeah, so one of the things that we are doing with our LiDAR is we have the RSU. We're going to set the RSUs up where the LiDAR sensors via the edge processor can communicate with the RSU, and so show information about pedestrians. So then if you had an OBU built into a vehicle, you would be able to see those pedestrians at the intersection as, on a screen as you're moving towards that intersection. So you would get information on those pedestrians moving up there. So yeah, that's one way you can display that information about vulnerable road users, to drivers who had OBUs installed. And so, yeah, I think there are a ton of use cases for RSUs, and we're really just scratching the surface with some of our proposed use cases for our grant. But I mean, there are all sorts of ways. You can set up TIM messages. You can set up the RSU, to show the traffic signals coming off the controllers. So there's just a huge myriad of use cases that we're really scratching the surface with the RSUs.
Okay. Thanks, Ryan. Danielle?
Yeah, so I would say that, so the vulnerable road user application that we're using is, right now, it's not fully operational yet, but like Ryan said, it's basically just to detect where the pedestrian is in the crosswalk, or even within that range of the crosswalk, and alert the driver. So that's really the only functionality we have. Part of all of this that we're doing is, I think our ultimate goal is eventually to get to snowplow priority, because that, here being in Michigan, that's a big application for us that we would find very useful. So we're just taking, I think, those baby steps to try to get to that point. But that's all we're doing with that information right now.
Okay. Well, being in Texas, part of the state, snowplows aren't really important to us, but in the other part of the state, they're really important. So
Yeah.
That's interesting. Blaine, is there anything you want to add?
Yeah, so we're broadcasting basic safety message from the vehicles we equip, and a signal request message if we are asking for priority and preemption from the roadside, SPAD and MAP. RTCM is something we're capable of broadcasting, and we do that from some intersections to help the vehicles be able to refine their position location. We're broadcasting TIMs, primarily not at signalized intersections, travel information messages. And our intersections are broadcasting an SRM to confirm the request of an SSM, a signal. I'm sorry, we're broadcasting SSM to confirm the request of a signal request. And at our vulnerable road user intersections, we're starting to use the SDSM, so that, because the LiDAR is detecting multiple individuals, not a single individual. And so we're sending that message to the vehicle that notifies the onboard unit where the various pedestrians are, rather than a PSM, which is meant, a pedestrian safety message, which is meant to be sent from a pedestrian as an individual. So those are the messages that we're using as we support priority and preemption at our intersections, and with our TIM messages, curb speed warning, disabled vehicle warning, spot weather impact warning, and we're working towards road closures and weather events as well with TIM messages.
Okay, great. Very important messages. Virginia, is there anything you'd like to add?
No, I think they covered some of all the major applications. So yeah, I think we're good. Thanks.
Okay. All right, great. So there is a question in here that is asking if any of you would like to share your view on direct versus network V2X, and if you are testing the differences between those two methodologies. Anyone?
So
Well,
are they?
I'll jump in if nobody else does. There are so for those of you who may not understand the difference, direct V2X is using the 5.9 gigahertz spectrum to broadcast directly between an RSU and an OBU. Network V2X is a broad term that generally uses cellular communication. It includes things like telematics that are built into the automobile you buy today, where your car is talking to the mothership of the company that made it, and other kinds of applications you can purchase. I think there are a lot of applications that work well in the network's V2X spectrum, and there's some pros and cons to using that. ITS America has a Beyond 5.9 committee that is exploring those and has put out some papers about that and is about to put out a list of use cases. We have not gone that direction. We've gone towards direct V2X. Our reasoning is, one, we're ultimately headed towards safety, and safety applications need ultra low latency, less than 200 to 300 milliseconds, and you need direct V2X today to do that. And secondly, we're looking at direct V2X as a broad range of applications, and that's what the automakers have told us they want to move towards, and we're trying to get ready for them. We want to make sure that when the automakers start putting V2X in their cars, we're ready, and so we're focusing on that area. There are other agencies that are looking at network, but at UDOT, we're really focused on direct. Some others may be able to talk about their uses of network.
Right. Thank you, Blaine.
I would say we're also focused on direct V2X here, and I think some of that gets back to what Blaine mentioned about the higher latency and just maybe the spottiness of the communications going down that route, but yeah.
Danielle, anything to add?
Just to add that we're introducing Network V2X in our test bed, so we'll be working on that going forward.
Okay, great. And Virginia?
I do think it's important to continue to explore both. That's why I really think that the working groups that ITS America have are good, is that they kind of advance both direct and networked communications. It just depends on the applications, and redundancy is never a bad thing in these systems. So to be able to provide the information in different ways, different alternative means for delivering it, I think it's worthwhile to continue to advance these different methods of getting the messages from point A to point B, so that we can build interesting applications and develop the standards and continue the discussion on this. So I think it's great to continue to explore both ways.
All right, wonderful. Well, we are so close to our time today that we are not going to have time for another question. I want to thank our panelists, Ryan, Danielle, Blaine, and Virginia. And I want to thank Kevin from ITS America for pulling together this webinar today so that our 4 panelists could share their expertise in this area. Thank you very much for joining us. Kevin, is there anything else to add?
No, I think you covered pretty much everything, Erika. Thank you so much.
Thank you.
And thanks to everyone who joined us today.
Yes, thank you very much.
Thank you, everyone. It was a pleasure.